So my name is David Loker. I'm Director of AI at CodeRabbit. I'm going to be talking to you about context engineering in the context of code review as it pertains to code review specifically. If you don't know, CodeRabbit is an AI code review tool, and you can sort of use it as a general tool to find bugs, find issues, and ultimately stop your engineers from banging their heads against the wall. So what is context engineering? It kind of starts back a little bit further. So as we know, prompt engineering was sort of the thing of the day. How do I prompt an LLM to do what I want it to do? So we all came up with these clever instruction sets. We figured out different ways of using it, but ultimately there was limitations, right? Depending on the task at hand, you might not know what you need to give the LLM at the time you're writing the prompt. So you're sort of limited by what you can do. It often fails, the model lacks the context, right? So you need to find some things you don't know at the time. That can be useful in cases where the context is actually present in the user's query to the LLM. And you can obviously use few-shot learning to increase the likelihood of your desired responses. But there's very, very hard limitations on how many times you can do that. So for example, I could say, write a summary of this code diff versus here's the acceptable code diff format, the information we're looking for. Here are some examples of things I'm expecting, depending on the input, depending on this is the output that I want. And then finally, you say, write a summary of the code diff. That's great. Very, very limited. And so this new term was coined called context engineering. Now, the way I look at it, context engineering is just a fancy word for I'm trying to figure out what exactly I want to put in the context window of the LLM so that it achieves my desired goal, right? So I'm designing that environment, that whole context window, and it's completely dynamic in order to what the model needs to do this job accurately. So what information can I gather? That's what I'm going to talk about in the context of code review, how you design that. So to set this all up, why do we care about code review at all when it comes to automation? So you have a few different types of companies, and I'm kind of lumping people into buckets here, but ultimately, obviously, people fall on the spectrum. We have the no-code review, right? You have a project, you have a new startup with one engineer, YOLO, just throw it up there, right? What could go wrong? That happens quite often, obviously. Wouldn't it be nice if you had somebody who could review your code for you, like CodeRabbit? Then you have them slightly more, you have a few more people, semi-formal. Maybe you're both working on something together. One person's reviewing your code. Technically, they probably shouldn't because they also had a hand in designing it or something like that. But ultimately, that's a quick and dirty peer review. Also, a lot of bugs sneak into production, and then suddenly systems go down, right? So again, not quite the gold standard, so to speak, of human review. And then you have people or companies like Google or large organizations like Netflix who have very, very comprehensive code review. It takes a lot of effort. And usually senior engineers or even higher people to actually look at that to decide whether or not your PR has any issues with it. And we're looking at things at bugs, yes, like typos, logic inconsistencies, concurrency issues, but also they're trying to look at it in the view of the code base in general, and does it fit in, and does it cause any secondary concerns that might happen outside of the PR itself. And you can start to see as we as humans review code, there's things that we do, right? And so what did we do? To make this system a little bit better for everybody, we started adding automated tests, CI/CD, right? Now we have static analysis tools added in, high false positive rate, limited scope, and obviously static rules, not exactly useful all the time. So manual code review is a huge bottleneck, right? 15 to 30% of the time of developers is going to be spent doing code review. That's a lot of context switching, and for large organizations, that's a lot of expense, right? And it's getting much worse. AI coding tools are worsening the review bottleneck. PRs are being created much, much, much more quickly. They're much larger. The size of the PRs is going kind of crazy, and you go to these other talks on code generation tools, and you see like I submitted a 15,000 line PR. It's like, well, great, now what, right? I mean, who's going to review that? I definitely wouldn't want to. And so we have this bottleneck now, right, in the code review process. And that's largely been a human problem. But if we're going to do AI code generation, if we're going to move forward with this, which we definitely are, you're going to need some help to make sure that that throughput remains strong so that you can actually get stuff out into production. And so we have the idea of context engineering. How can I do a code review? How can I automate that process? Obviously, prompt engineering is not going to do it. I can't just stick a diff in and have some fancy instructions that I've cooked up beforehand to cover all of the various cases that could possibly come up. So rather than thinking about the prompt, I need to think about what is the information that I, as a human, would use and what process would I take to do a thorough code review. If I come into a new code base and I look at your PR, I'm going to have no idea what's going on in the larger system. I need to do some research. I need to understand the code base. I need to look at potentially architecture diagrams. I need to clone the repo, right? So we have a lot of stuff that goes into the context as a human to figure out whether something is right or wrong, and we do the same thing. We look at that process, we figure out the stuff that we would need, and we give it to the LLM so that the LLM could finally do what we do, right? And so that's the idea. And I'm going to go into a lot of these different pieces as I talk through this, right? And we'll go into more detail on what these things mean. So we have a few things, right? We have the repository. Obviously, we need that. We need the code. But we can't put all the code in there, right? We need to do some fancy stuff there. But we have a code graph analysis. That's something that we've done where looking at your PR, we kind of spiral out into the code and figure out what does this touch? What functions does it touch? What variables does it touch? What other imports does it touch? So we can figure out what files and what information might be necessary. Static analysis tools still play a role here as well. We look at them for information about where there might be errors because there is a high false positive rate. The LLM will then look at that, reason through with all the other context to figure out, is it really there or not? And if it is there, why? What is the reason? So that we can surface that information. You have web queries, and this is extremely important when you have LLMs with cutoff dates, right? So library usage, if you use a new library that didn't exist when the LLM was trained, well, guess what? It's not going to have any idea whether you're using it correctly or not. So we need to know what library version you're using, and we might need to download some documentation, for example, right? Integrations using MCP, we were just talking about that earlier. MCP support, to be able to pull in documentation, coding guidelines, or any other information you might think would be necessary, like why are you building this, the issue that spawned this feature, right? Not just what you built, but why you built it, because maybe you didn't build it according to what the issue said you were going to build. Can you tell that that's there? That's something that is way beyond if something is broken in the code from a logic perspective. We're talking about, did you follow what the issue said? And then we have a big knowledge base of information that gets built up over time, and I'm going to get more in details on that a little bit later. MCP is like a great tool, right? You can pull in all kinds of information from lots and lots and lots of different sources. There's so many different MCP servers that you can set up now. And ultimately, that gives you access to information that otherwise you wouldn't. However, as anyone who's used an MCP server as a source, you get a lot of tokens as a result of doing MCP search. If I give the LLM the ability to query these tools, I get a lot of stuff back. And the context window is finite. So you have to make sure, the problem is keeping that context window bounded. So you need to figure out, why did I call this in the first place, look at the information, and then distill it down to the answer to the original question, right? So you get rid of all of the extra. I talked about linters. This is an example of taking a linter warning and turning it into a why. Why is this there? What is the actual bug? And how then could I potentially fix that bug? This is where LLMs sort of provide that extra benefit over top of static analysis tools. And this is one of the biggest ones. So the outside diff impacts slicing. What do I mean by that? So the PR itself has some information in it. And yes, there can be bugs in there, right? There can be logical errors. There could be some sort of inconsistency between what the person wrote in their comment versus the code they wrote. The issue might be slightly done wrong, used the wrong constants, or any other number of things. But in our experience, most bugs hide outside of the diff, in the contract that you either altered or that you're making use of from the code outside in the rest of your code base. So here's an example which is poorly formatted with a tabbing issue and various other spacing problems. You can see what's happened here is the process refund now raises an exception, but the handle order wasn't updated. So this is an example. If I change process refund to do that and I don't update handle order, I've introduced a problem. And unless I brought that other code in there to look at it, I wouldn't know. And so this is where you have to pay attention to what the outside diff impact. The knowledge base is actually a very, very important aspect of a user's ability, in our case, to control and influence how things are done for them specifically. It's a personalization kind of approach, right? If I can learn from the user over time how they like to do code reviews, then I can make sure that the code review is done according to that organization, that repository. And so this is a few things. You can have path-based instructions in our case, so tell me that all TypeScript files must behave, you must look at them this way, in some way that you do differently than other people, right? Something that someone cares about is a standard pattern. You do things differently. You can affect the outcome. You can look at past PRs to understand, was this attempted to be fixed before and it failed? Is there something else, a pattern, for example, of authentication that I need to look up so I can tell whether you're following the standards within this repository when it comes to auth? And all kinds of information can come from that, right? You can look up coding agent guidelines talking of AI-generated code. People put a lot of effort into perfecting these Claude MD cursor rules and various other agent MD files. There's a lot of information in there that can be extracted, right? To make sure that, again, after the code is generated or built, when we review it, we can double check to make sure that the system actually followed those rules. And then we have learnings. And learnings is actually something that is extremely powerful and I think underrated in this current. You can chat with the bot, and the bot will pick up on that conversation and use that information for later. If you tell it, we don't use camel case, we use other things, and you just chat, it'll be like, okay, good. And later on, it'll be retrieving that information for future reviews. And so paying attention to what's happening, right? And so all this stuff plays in. And finally, after you've gotten all of this context and you've figured out all the different pieces and you've shrunk it down depending on the exact things that you think you need, you have to find some way of sending it to the LLM, and a standardized format, for example, would be JSON, right? There's just a little bit of a problem with JSON. It's getting better, to be fair, but models aren't largely trained on JSON as input, right? They're trained on lots and lots and lots of human text. We don't talk in JSON. So if you want to get a little bit better understanding from most of your models and use less tokens, because JSON uses a lot of tokens, you can just use tag-based alternatives, right? And those tag-based alternatives, if you use human legible tags, the LLM is far more likely to understand you and get less confused, especially for very, very large contexts. So this is just a kind of example of what I call a prompt envelope, feeding the information that we just gathered to the LLM. Oops. So I want to show you a couple of examples, and I took them out, but I think given that I didn't know if I was going to have my laptop, so given that I do, let's see if I can actually just show it to you. So here's a review in open source, and I want to go to the top here. All right, so right now, given all this information, we generate all this extra stuff. Like, what is happening here? What are the files changing? What is all the information that I've gathered? And you can start to see already some semblance of us finding context from elsewhere and pulling that in. So these are related, possibly related PRs that we've pulled in to see what's going on, to try and understand it. And during the review itself, let me skip down to the review comment, we can see under the review details, we have additional context used, and there's a lot of stuff in here. So this person has been using CodeRabbit for quite a while. And so there's a lot of personalized information that's going into the code review. This, again, is something that's picked up over time and stored. And then we have code graph analysis, another tool that comes in and tells me, for this file, auth-context.tsx, I found some information from a different file that's related to it. I'm going to add that to the context window when I do that review. So when it writes all these comments, that's where all that stuff is coming from. And I have another one over here as an example of path instructions. So this person has taken time to say for TSX files, this is a specific instruction. Use each feature flag in as few places as possible. If a flag must appear at multiple call sites, explicitly flag this for careful developer review. So something very special to them that they understand that they don't want within their TSX files. So all this comes into, again, like, what would I do as a human, right? How would I do things? And so I built a little example of a very, very simplified review system to try and demonstrate some of the differences of these various approaches of doing context engineering. So in this particular example, I didn't want to run it just in case it took too long, but this one, we don't have outside diff. So it's just the PR, it's just a few pieces of information, everything that changed, but there is no outside impact information. And it didn't find anything wrong, but there is definitely something wrong because I inserted a bug into it. The second one, I used JSON, I just threw everything. Every single thing that was connected to that file, I threw it in. So you can see the last one, actually, maybe I didn't point it out, ran in 10 seconds, had 17,000 tokens, that was just the diff. There's 110,000 input tokens in this one. It found it, right? There's the bug. 38 seconds. So at least it did that, right? My final one is an example of, I used the slimmed prompt envelope. I used just the information that it needed, just the impacts that actually connected to the diff itself. So I did a little bit of thinking around what I would care about if I was a human and optimize the context. Because context engineering isn't just about retrieving the information and throwing it in. We only have a limited space. You have to think about, how do I optimize that space as well? And so here I've optimized it. Here I've only 18,300 tokens approximately. So it's only 1,000 tokens more than just the PR diff itself. And with that, I was able to find the same bug of 110,000 tokens. So that's what I mean by context engineering. You need to think about that optimization problem because you only have a limited number of space. And also you don't want to spend an extra 90,000 input tokens over many, many, many PRs, right? And it also runs faster, to be fair, which also a lot of users care about. So that's my example. Those are my examples. So let me get back to this. What time are we at here? Okay, we're good. So these are some images of the things we just showed. Again, 110,000 tokens versus 17,000 and 18,000 at the last. So let's get past. I wanted to talk about one more thing before turning it over to you to ask questions. I found this paper fascinating. It's relatively recent. Stanford and others published a paper called Agentic Context Engineering, ACE for short. Generally speaking, most people have been using LLM fine-tuning, using reinforcement learning or some other approach in order to have the LLM achieve better results in their specific vertical. And for a lot of verticals, that makes a lot of sense. And ultimately, if you have the budget for it, then, definitely worth the investment. This approach does not require you to do any kind of actual LLM fine-tuning in order to achieve better results. And it relies on this idea of context engineering being a problem that needs to be solved and needs to be optimized for. And so this is really cool, in my opinion. This, you can take what you've generated with the thought tokens, the output, and look at it and reflect on it and say, did it achieve the goal I set out to achieve? And if there was something off, I can ask, why was it off? This is what I was expecting. How would I have been able to change or edit the strategy or the prompt itself in order to achieve that goal? Right? And then based on that, you get a bunch of things that you can actually look at. So I don't get a black box LLM now that I can't necessarily figure out what changed. I can actually see every single thing that this has done, and I can tell whether or not it makes sense for me. And maybe I can actually use this differently for every single organization. So there's a personalized version of this. You have a different version. This other person has a different version, right? And so that's very powerful when you're talking about trying to build context. And I know it's editing a prompt, but your prompt can be a strategy for curating context. And that prompt can be updated. So it's not necessarily having to give explicit instructions, but to say, in this case, this is a better strategy. You should be using this context more than this. This is the thing that you should be looking for. And so that is the approach that I'm referring to. So after each review, tracking which signals led to helpful versus noisy findings, right? Taking that, feeding it back into the system and asking a question, right? Most valid issues were tied to AST-GRET matches. Lint-only comments were rarely accepted. Things like this to understand, well, maybe linters aren't doing what I wanted to do for this org, or they don't care about them. I should turn them off and ignore them. That would save me some money as well. And then finally, you get the final answer, like, how do I curate all this stuff? And I can look at it, and I can decide whether or not that makes sense, or whether I think it was just a one-off outside thing that I don't want to add to my prompt. And so I've been using this for a while. In CodeRabbit, we have something like this. Instead of an automated approach, we've been crowdsourcing it. I referred to it earlier. It's called learnings. The user comes in, it tells me, and they tell me what went wrong. And I take that back in, and I feed it into the context window at the appropriate time, and that changes the result. The only difference is this one is obviously going to be much faster and more automated, right? But yeah, it's a very powerful concept. We found learnings to be extremely, extremely valuable, and I think the research from here kind of bears out how it can boost overall effectiveness of the prompts and the context that's getting curated. So a few things, takeaways, I think, from this. LLMs reason better with better context, and more context is not always better, right? Domain expertise is what equals better context. What is the problem that I'm trying to solve? How would I try to solve it? And if you don't know, find someone who's an expert who does. What process did they take in order to solve the problem? And how do I automate or leverage that in order to help trim out things that are, technically speaking, maybe tedious for that person, right? And that's how you get into the better context. So things to try. I mean, I have an open source repo related to the demo code that I ran. It's just a very simple review file. You can fool around with it. You can feed it different types of input, different types of context to figure out what works. And I also wrote another article about this where you can see a list of things that I suggest trying out. But yes, build the context. Don't just prompt the model. I think that's the main takeaway here. I would like to open it up to questions. How are we doing on time? Okay, we're good. Yeah, sure. This gentleman, yeah.
I run on zero. Yes.
It might be on now. Try it again.
Oh, okay. Yeah, that was very helpful. Thank you. So if you just take a quick step back in terms of like general context engineering and managing context, obviously building things that are very specific to that domain, tools that help collect the important information to do what it needs to do, that you showed that the learnings is definitely important. But as your tool is helping developers manage their context, you also, the tool yourself, have to manage your own context, and context still gets bigger, it gets a little less accurate. I was wondering how you guys manage your internal context, if there's other tricks to that?
Yeah, so I think in our tool, all of the context is actually managed by us, right? So you build, let's say, your code, you spawn up a PR, the PR automatically triggers us, and we then go off and we have to build our own context to try and understand that. So I guess in a sense you have the PR, but we're actually even doing more work on that PR to understand what's going on so that we're not blowing the context window. So there's a lot of stuff and optimizations that are going in there to manage that. But yeah, context window is finite, right? So if it's a very large PR, we're going to look at, for a group of files that are really related to each other, we might do them in batches in order to do that, right? And there's a lot of, this is a multi-step process. So we don't just have one step with one context window. There's also an agentic system that will do an exploration step if it needs to pull in additional context based on that review. So it's a whole hybrid architecture of both a workflow and a couple different agent steps in there.
I think we had one more back there.
I think there was one over here too. Yes. Yes.
Hello.
Hi.
I was wondering if you've had any customers that have adopted it, and there might be one person on the team who's putting learnings in there that they don't want, and how you overcome that.
Yeah, so typically speaking, we haven't encountered it too much, but you can curate your learnings, yes. So there is definitely, there's also at every single time it gets used, it tells you. So if there's something that's not doing, you can actually say, oh, that learning doesn't apply, and it will remove the learning. So there is a way to chat with it that will be like, oh, I didn't mean that. I was in a fit of rage at the time, and there was something wrong there. What's that? We can go somewhere in the middle over there. I can see a gentleman right there in the middle. Yeah.
So agents.md is a popular approach that everyone is taking right now. I mean, you must have seen that. So is this go in hand with agents.md, or it's a different one?
Sorry, I didn't quite catch the last part of that.
So is this like in hand with, can we build agents.md using CodeRabbit, or we cannot?
Sorry, can someone help me? I can't understand the question.
Agents.md?
Agents.md. Oh.
Yeah, so that's a popular approach people are taking from last couple of months. So I was thinking that whether can we build agents.md using your tool, or?
Yes, so all of these Claude, cursor rules, agents.md, they are all automatically taken into account within the review process. Because yeah, people are spending a lot of time perfecting these files, right? Ultimately putting a lot of instructions in there. So yes, we review all of those and bring them in. And again, we can't bring in the entire file. Sometimes those files are really large. So finding which parts of that file apply to this particular file or this particular review is also part, again, the optimization problem of fitting the context in there. I think you had it, yes, very early on.
Okay. So my question is, we all see how fast that LLM is improving right now. Yeah. So, and today, there are a lot of intermediate information saved, right? Try to work with LLM. But maybe next year, are you worried like next year maybe LLM, Codex, or some of like Cloudy, they become so smart. You just throw your PRD to it, and it will keep working by itself and deal with everything, all your concerns, and just generate a perfect coding,
Mm-hmm.
Don't need to worry about anything at all.
Yeah, potentially. Ultimately, does it have all the necessary context in order to review itself is the question. So even if I have a staff level, principal level engineer generating code, I'm still not just going to throw that code into production, right? There's a lot of things that might go into play there, and LLMs do get better, and we're incorporating them into the system also takes a lot of time. But there's also potentially context that they're not currently accessing at that time. And everyone, ultimately, at the end of the day, you shouldn't maybe generate the code and then let the same system that generated the code evaluate it, right? It usually, at least in my experience, wants to say, I did a good job, for the most part. So there's a lot of things around, for example, pulling in Notion documentation and pulling in coding guidelines that you may not have given it the right complete instructions. It may not have had complete context or maintained that context for the entire time it was generating that code. So for example, I will give Claude sometimes this instruction of like, when you go through this markdown file, the spec, make sure you tick off and go through what you're doing. And as you complete something, review it, and ultimately then create a commit. And it will do it for the first 3 tasks, and by the 4th task, it forgets. Because the context window has gone by, some compaction has taken place, whatever other thing has happened, and it has forgotten. Because there's also this mathematical problem where the more you put into the context window, there are pieces of it that it might just forget. And so that optimization also is extremely important. But it ultimately comes down to, for us at least, most people that we know that are using AI-generated code, it has way more bugs than if a human was to write the same code. And so, yeah, there might be a time when that's not the case, but that is not right now. And so the problem right now is that PRs are being reviewed too slowly for most people to bring code into production. You're having a lot of stale PRs because people are opening them at a faster pace than they ever have before. And that's a problem from productivity perspective, as well as from launching new features and new things into production.